Okay, Bismillahirrahmanirrahim. Today we do the examples of the DFA. Okay, we have the deterministic, finite order, and we know it has to have the five tuples, these things, right? So, if we have to create a state diagram, we have to create what? State diagram like this one, which is on the bottom, which we have seen yesterday. If we want to create the state diagram, so how do we create a state diagram? Let's have some understanding of it, right? First thing is that you have some states, which is a queue. Okay? Say for example, let us try to create a, then we will see the examples from the book. Okay? Let us try to create an example, create a machine, abstract machine, an automaton. Let's try to create an deterministic finite automaton which accepts a language with an alphabet having the alphabet A comma B, only 2 letters. So we have the sigma here, A or B, and what kind of strings we can have from this? We can have the epsilon empty string, we can have string like A, we can have B, we can have AA, we can have BB, we can have ABA, we can have anything, right?
Yes.
It is infinite set of strings we can have from this. So if we choose a particular set of strings, we satisfy something. Say we satisfy this thing, that I am saying all those strings from this alphabet, we start with A. We start with
A.
So we want to design an automaton which accepts this language. Okay? Which language?
String starts with A.
That no, I'm saying which language? That the string starts with A. Because it could start with B now also. We could have BA also. A string, right? From this. We could have B also. But if we give B or BA or anything which starts from B to that machine, it should reject it. It should
Reject it.
Okay? So firstly, if we have an automaton which accepts that language with having, that means I can have from this alphabet AB, I can have infinite number of strings. From those I am having only those strings which start with A. Like A, like ABA, like ABBA or something like that. But it should start with A. Right? Now to design a state diagram firstly, because this automaton will be nothing but a set of states with some transitions. Right? Now, if we have a state, we showed with the circle, and an arrow like this coming from nowhere, it is the start state. It is the start state. It is the. If my start state is also the final state, if my start state is also the
Final state.
then what does it mean? What does it mean right now? Right now I am having no inputs, right? My start state is final state. Use your brain. What does it mean? Is it accepting any language? Yes. Beautiful. Very good. It is accepting epsilon, empty string. Because nothing is coming, still it is okay, it's my final state. Nothing is coming, still it is a final state, no? So that means it's accepting epsilon. Epsilon still can be a language while we have nothing, right? Because from the alphabet A comma B, the minimalistic thing is the epsilon. Epsilon, right? Which has no input. Then we can have A, B, we can have other things, right? For a time being, we are saying that we have one state. This is my state. This is the input state. Okay? And I am saying that I have the input A. Input?
A.
If input is A, because I am saying my language is what? Okay?
String starts with
I could
A.
say my language is W such that W, any word, any string, okay, such that W starts with
A.
and it is implicit that this W belongs to alphabet.
Yes, sir.
This W belongs to, we know that, okay? We can add it in the language also. This is my language, this is my, and I said if I have an automaton which accept all these strings, which satisfy this language, then that language is called regular. That language is called if we can design an automaton which accepts this language, then that language is regular, simple as it is, right? Now, I am saying I have a start state, so my sigma is what? A comma B only. A comma B. That means inputs can be in terms of A's or B's. So on this state, say Q0, this is my Q. What inputs I can have?
B and A or
A as well as B. If A comes, if A, it will go to the other state.
Q1.
Say Q1. And this is my final state. This is my,
Final state.
because I know if A, only single letter A comes. Because when you design a DFA, you have to see the minimalistic. You have to see minimalistic automaton, which can represent simplest of all the languages. That is single A. Okay? That's what? Because my language is which starts with A. Which starts with only that thing should be accepted. If it is epsilon, don't accept it. Okay? My language says if it is an empty string, don't accept it. If it is starting with B, don't accept it. If it starts with A, accept it. After that, it could have anything. After that, it could have, say my string is AB. What do you say about it, AB? Should it be accepted in my automaton?
Yes,
Yes. But after A comes in, now I am getting the B. Now we are getting the, where should it go? This is Q0, this is Q1, yes. If B comes here, absolutely. Because you have to accept it, na? If B comes after A, you have to accept it. At who? Which state is my accepting state? Q1 is the final state. अगर A आया, ठीक है? It went from Q0 to Q1. Q1 is the final state. So my final state is the Q1. Right? Now I am saying कि A आया, गया इधर, उसके बाद B आया. So इधर कहाँ जाना चाहिए B पे? तो यार ये eraser कैसे जाना? This is Q1, right? This is accepting state. अब यहाँ से ये आएगा तो कहाँ जाएगा? अगर B आया, अगर A भी आया, A comma B, दोनों आए, still is accepting because initially I have the A, I got the first letter A, I got the first letter what? I got after that कितने भी A आए, कितने भी B आए, वो सब accepting है. वो सब क्या है? So that means they all go to the self loop. Clear? But what else? What if from the Q0 the initial letter came B? Initial letter came?
B.
Does that satisfy my language?
No.
Should we accept that?
No.
Should that go to the final state?
No.
आपको कहाँ दिमाग है? Should that go to the final state?
No, sir.
Because my language says it's accepting only those letters which start with A. So I cannot. But so can we have that input B?
After A, none.
Can initially we have the input B? Why not? Because my alphabet is A comma B. Anything can come from this alphabet. Okay? Because your language is made from this alphabet, anything can come from this. But if B comes, my automaton should reject it, should not accept it. Accept का मतलब हो गया कि you have landed to this state, final state. Reject का मतलब हो गया you have not landed to the. So maybe the B comes, maybe the
B.
it will never get you to where. Whatever.
Final is the accepting state.
It will never get you to where.
Accepting state.
So what I am saying is if there is an input A from a state Q0, which is my initial state, initial state shown by the arrow, and it goes to the second state, the final state Q1. After A comes, then A come or B come, doesn't matter. Many times.
Yes, sir.
Infinite many times. A आ रहे हैं, B आ रहे हैं, इनकी combinations आ रही हैं, A B A B B A, पता नहीं क्या आ रहा है. लेकिन पहली बार तो A आया था ना, so we gonna accept. Now B भी तो आ सकता है ना? From my sigma, because I say sigma is A comma. This is my, the alphabet. My alphabet A comma B. B can come. B can, but it cannot go to accepting or final state. Rather it goes to some other state, say called Q2. Q, and this state is called dead state. Because after it went to the Q2, the moment initially the B comes, see, look here. The moment B comes, B is going nowhere now. It's going what? So that means it's rejecting. It straightly rejects it. It will not take any input after that. It will reject it because इसके बाद ये कहीं नहीं जा रहा ना. It doesn't go to the final state. So the moment is initial letter is B, you are stuck. Can you go from here anywhere?
No, sir.
No, you can't go. So that means it's rejecting my W, the word. But if the A comes, where it goes? It goes to the accepting state, right?
Yes, sir.
And after that, any A becomes. Can we do same thing with the binary? If I have the 0 comma, if my alphabet is 0 comma 1, and I am saying that I have a language which starts with the 1. Which starts with? It should start with 1. Okay? It should not start with 0. So what shall I do? This is Q0. If the 1 comes,
Q1.
it will go to?
Q1.
Should I accept it or not?
Yes, sir.
Minimalistic.
Yes, sir.
क्योंकि मैं कहता हूँ कि लैंग्वेज है जो 1 एक्सेप्ट कर रही है. 1 एक्सेप्ट. So उसके बाद कितने भी सारे पे 1 आए, लेकिन अगर खाली 1 आया, input is only 1, it should accept it. So design a DFA for the minimalistic string. Okay, input. Now इसमें मिसिंग क्या है मेरे पास?
0.
यहाँ पे अगर फिर उसके बाद 0 या 1 आएगा, it stays there. It will all accept it. 0 आ रहा है, 1 आ रहा है, accept. ठीक है? Because all this after this is accepting, right?
Yes, sir.
What about 0? Can 0 come at Q0? Yes, because my alphabet has 0, right? But what will it go? Where will it go?
Q2.
It will go to the other state Q2, which is my dead state, right? So it's not accepted. Simple as it is. It is 0. Now, can we in this? What is Q here?
Set of
Finite set of states. How many states I got?
3.
Does it make sense?
Yes, sir.
What is here the alphabet?
Finite set 1 alphabet.
0 and?
1.
What is the transition function?
1.
Huh? If you got 1, it go to Q1, or if you got 0, you go to the
Q2.
Q2. But from, if you have starting from Q0, from Q1, if it is 0, it will stay at Q1. If it is 1, it will stay at Q1. What about the Q0? Which is the initial state?
Q0.
Q0 is the initial state, right?
Sir.
What is F final state? Which one is final state?
Q1.
Does it make sense now?
Yes, sir.
Let us see the examples from the book now. Hopefully you can do now in DFA. What do you say about this? Prima facie. Look at this. What is it accepting? Tell me. From this diagram, what is it accepting? So which is initial state?
Q1.
Which is final state?
Q2.
Q2 is the final state, right? From this, so that means something is accepting, na? So the arrows which are coming to Q2 are accepting it. So there are 3 arrows, 1, 2, 3. They are coming to it. So if this comes, when will this can come?
1 आएगा तभी Q2
when जब 1 आएगा, अगर 0 आएगा वो कहाँ पे रहेगा? तो 0 में यहीं पे रहेगा। लेकिन 0 के बाद क्या आ रहा है मुझे? यार डायरेक्ट 1 ही आ गया। It will go to accepting state. और फिर अगर यहाँ पे 1s आए वो कहाँ पे रहेगा? All the time accepting. And what about the 0? If the 0 comes from Q2, it go to
Q3.
But after that, if 0 comes or 1 comes, it goes where? Think about it. So this is our Q. There are 3 states. This is our alphabet, and transition ये हमारा table है ना? So what is the A? Look at this. A is the set of all strings that machine M accepts. है ना? So we call A as a machine of language of machine, right? So what is the language which a particular automata accepts? ठीक है ना? From a particular alphabet, what your machine accepts, only those strings that form a language A. That form a language. ठीक है? This is the definition of automata. That is language. Because what is accepting? What is my language here? W such that W contain at least one 1 and even number of zeros follow the last one. Last one के बाद there should be contain at least one 1. पहले तो इसमें एक 1 तो होना चाहिए, है ना? यानी कि अगर आप इसके ऊपर हो, यहाँ पे हो, अगर आपको खाली zeros हैं, तो कहाँ जा रहे हो? The moment एक 1 आ गया, फिर कितने भी 1 आए कोई प्रॉब्लम नहीं है ना? फिर कितने भी 1 आ गए वो मसला, लेकिन उस 1 के बाद चाहे एक आए 50 1 आए, उसके बाद कम से कम 2 zeros आने चाहिए आप, या even zeros आने चाहिए। देखिए फर्ज कीजिए मेरे पास एक इनपुट मेरे पास है, my input is 0 0 0, okay, then I have 1 1 1 1, okay, then I have 0 0 1 1. I am saying, is it accepting or not? I am on 0. What will happen? It will stay here. Again 0. Stay here. Again 0. Stay here. Right? Now I got 1. It will go where? Q2. After that I got 3 1s. On 3 1s it will stay here. Right? After that 0 0. The moment I got 0 0, it will go here, come back. Right? After that I have any many ones. It will stay. So I have even number of zeros. If I have even number of zeros, firstly I would have at least 1 1 to go here to the accept. Because अगर 1 नहीं आया तो उधर नहीं जा पाएगा, ठीक है ना? एक 1 आए फिर 50 1 आए या 100 1 आए, because it's, with the 1 it stays there, right? After that it has to come back. अगर उसके बाद इनपुट आपका आ रहा है ना 0 फॉर एग्जांपल, इन वंस के बाद इनफाइनाइट वंस आप कितने भी 1 डालो, लेकिन अगर कहीं पर भी 0 आ गया, इट विल गो देयर. It can come back only if 0 comes. If 0 comes or 1 comes. फर्ज कीजिए 1 ही आ गया, तो फिर भी 2 zeros मेरे पास, एक ये था, एक यहाँ से है, एक यहाँ से, ठीक है? लेकिन यहाँ no, he has done wrong. He has done wrong. क्योंकि ये कह रहा था उसके बाद even zeros होने चाहिए, तो even zeros में ये 0 ही होना चाहिए ना, वापस आएगा, तब जाके तो 2 zeros आ गए ना. अगर ये 1 से यहाँ पे आ जाता है तो सिंगल 0 पे आ गया हमारा, ठीक है? Let us see again the definition of the language. At least 1 1 and even number of zeros follow the last one. जो last one होगा, even number of zeros follow the last one. लेकिन जो लास्ट 1 होगा उसके बाद इवन नंबर ऑफ zeros है, तो उसका मतलब ये होगा ना कि ये 0 पे वापस आएगा, ठीक है? यानी कि आपको कितने सारे भी 1s हैं, आपने बोला कि ये मेरा लास्ट 1 है, ठीक है? आपने पहले 1 डाला, हो गया, आ गया यहाँ पे, इनिशियली आपके पास कितने भी जीरोस हो डजंट मैटर, द मोमेंट इट हैज 1 इट विल कम हियर, ठीक है। अगर आपके पास एक 1 आ गया तो हो गया काम, इट्स एक्सेप्टिंग। मुमकिन है कि इस 1 के बाद आपको जीरोस है, क्या है, अगर 3 जीरोस है, क्या है, फ्रॉम 0 गो हियर, फ्रॉम 0 गो हियर, तीसरा 0 टेक इट हियर, नॉट एक्सेप्टिंग, ठीक है। अगर 4 जीरोस है इट विल कम बैक, एक्सेप्टिंग। 5 जीरोस है, नो। 6 जीरोस है, यस। 7 जीरोस है, नो। 8 जीरोस है, इवन नंबर ऑफ जीरोस। लेकिन अगर हम ये 1 रख रहे हैं यहाँ पे, ठीक है, तो फिर ये 1 पे वापस आएगा ना, वो तो एक्सेप्ट हो जाएगा। तो इवन नंबर ऑफ जीरोस, यानी कि लास्ट 1 के बाद, लास्ट
1 के बाद
मुझे ऑड नंबर ऑफ 0 से ही फिर ये आ रहा है ना वापस। अगर ये 0 और 1 से वापस आए तो मुझे यहाँ भी चाहिए 0, यहाँ भी चाहिए 0, ठीक है। सो आफ्टर दिस इनफैक्ट आई कुड हैव कि यहाँ पे 1 है, यहाँ पे आई कैन ऐड इट कि आफ्टर लास्ट 1, ठीक है, आई कुड हैव 0 देन एनी मेनी वंस, बट द मोमेंट अनदर 0 कम्स फिर ये लास्ट 1 नहीं बनेगा। सो आई डोंट हैव टू यूज दिस बिकॉज़ लास्ट 1 नहीं बनेगा ना ये, अगर मैंने यहाँ से 1s लगाए तो लास्ट 1 यहीं पे आना चाहिए। इफ आई हैव लास्ट 1s आई हैव व्हाट, जो मेरा लास्ट 1 वो इसमें आएगा ना, उसके बाद 2 0 से ही वापस आएगा, ठीक है। सो वी डोंट हैव टू राइट दिस वन, गेटिंग द पॉइंट। You have to read this book, okay, revise it, read it again and again, and you will understand. So what is A? A is a language which is actually consisting of some words or strings such that which contains 1 1 and even number of zeros. So language M1 is equal to A, okay, or we could say कि machine जो मेरा M1 है it recognizes it. Now tell me about this automata M2. What do you think about this automata? Now you should be able to tell me. Concentrate on this board.
any string that ends
Concentrate on board.
any string that starts with 1 and ends with 1.
Huh?
Any string that starts with 1.
Which state is the final state?
Q2.
When will it go to, first see the minimal. First see minimal when it go to Q2.
जब उसको 1 मिलेगा it will go to
First see minimalistic. Minimalistic में क्या है कि पहली बार 1 आ गया, अगर एक भी 1 आ गया it goes to Q2, है ना।
only except 1.
उसके बाद जितने सारे 1s आते हैं it stands to Q2, लेकिन अगर उसके बाद 0 आ गया it
वापस
will go back to there, ठीक है ना।
It means any string that starts and ends with 1.
Think about it, tell me. So we know all this, right? We'll see the language. What is the language? W such that W ends in a 1. Just 2 minutes, huh? Only 2 minutes. But W such that W ends in a 1. It is ending in a 1. It's ending in what? Right? If the end is 0, if the last digit is coming 0, the moment if you have zeros, no problem. The beginning can have any many zeros. लेकिन end 1 से होना चाहिए. End किससे होना चाहिए? First ये मेरे पास है 0 0 1 0. It will not accept it. It's non accepting. 0 0 stay here, 1 go here, 0 come back here, non accepting. Last पे 1 होना चाहिए because we'll be back to this. So the ending should be 1. It is that machine. So this DFA is telling me that the ending should be 1. So it accepts this language. Okay. So my language is being accepted. Is W such that W ends with, that's all for today. You close this.